Hi, this is an introduction to the two special right triangles. There are only two special right triangles, the 45-45-90 and the 30-60-90, and they're just basically named by the angles in the triangles. So I'm going to show you where these come from algebraically. If you take a square and you draw the diagonal, it creates two 45-degree angles, and we know that all squares have four right angles. So we really have two special right triangles in the square, and they're both 45-45-90 right triangles. The goal here will be to show the length of the diagonal in terms of the side x. To do that, we're going to use the Pythagorean theorem, and we know that we have a right triangle, so x squared plus x squared is equal to d squared. And we're going to try to solve this for d. So we'll combine the x squareds. We have 2x squared equals d squared. To get d by itself, we're going to have to take the square root of both sides. And then the square root of d squared is d. And we'll also like to try to simplify the square root of 2x squared. So 2x squared can be broken up into two parts. The x squared can be separated from the 2. The square root of x squared is just x. So d, the diagonal, ends up being equal to x times the square root of 2. And that's always going to be the case for all special 45-45-90 right triangles. So in a 45-45-90, you have two legs and then the hypotenuse. The hypotenuse is always going to be the longest side, and that's going to be the side that's equal to one of the side lengths of the square times the square root of 2. You can tell that you have a 45-45-90 right triangle based on markings, if the angles are marked equal, or if you're told that you have two 45-degree angles, or if you're told that the two sides are equal and it's a right triangle. So there's a lot of clues that can tell you that you have a special right triangle. In general, we basically look at it as two sides are called x, and the hypotenuse would be x times the square root of 2. So all 45-45-90s will follow this pattern. We're going to practice here. So if you're told that one side is 6, we automatically know the other side has to be 6. And then the hypotenuse is going to be 6 times the square root of 2. If that's an 8, take a second to find the other two sides. You can pause this for a minute. So the other side is going to be 8. The hypotenuse is going to be 8 times the square root of 2. You can pause it again if you're trying to find the sides. The two sides will have to be 5 and 5. Once you get the hang of this, you can follow the pattern. The two sides here would have to be 10 and 10. This one might be a little bit of a curveball, but if this side is the square root of 2, then the other side has to be the square root of 2. And then think about what the square root of 2 times the square root of 2 would come out to. Any square root times itself gives you the number underneath that root. So the hypotenuse here should be 2. If you have one side that's 3 root 2, the other side would also have to be 3 root 2. And then the hypotenuse is going to be 3 root 2 times square root of 2. Again, square root of 2 times square root of 2 is 2. And then 2 times the 3 will be 6. This one, you'll have to work backward a little bit. We know that this 8 is really the side length times the square root of 2. So if we worked backwards, we would need to know that the square root of 2 was multiplied by another square root of 2 to give you a 2. And then 2 times 4 is equal to 8. So if we let the side equal 4 root 2, we could see that if 4 root 2 was multiplied by the square root of 2, it would have to come out to 8. You can solve this by writing it out on paper and thinking about it, but really you're thinking about some number times the square root of 2 has to come out to 8. So usually I take that number, and if you divide it by 2, you get 4. And then if I attach a root 2 to it, 4 root 2 times root 2 would give me 8. This one's 20. If I take that and divide it by 2, I get a 10, and then put a root 2 with it. 10 root 2 times root 2 would give me 20. Okay, now we're going to look at the 30, 60, 90 right triangle, and that comes from looking at an equilateral triangle. An equilateral triangle, remember, has 3 angles that are 60 degrees and all the sides are equal. We could draw the altitude that goes right down the middle, and that splits the top angle into two 30-degree angles. So here we have 3 sides, XX and X, and the altitude we'll call A. And if I take that bottom and split it in half, the 2 bottom pieces are X over 2 and X over 2. So again, I can use the Pythagorean theorem, X over 2 squared plus A squared is equal to X squared. That's directly from the Pythagorean theorem. And again, I want to get A squared by itself here. So I'm going to have to bring the X over 2 squared over to the other side by subtracting it. And then I could get a common denominator if I want to subtract or combine X squared minus X squared over 4. And when I do that, 4x squared over 4 minus 1x squared over 4 is equal to 3x squared over 4. And then I'll take the square root of both sides. To do that, when I take the square root of a squared, I get a. But the square root of 3x squared over 4 takes a little bit of straightening out. So I can simplify square root of x squared is equal to x. The square root of 4 is equal to 2. So in the end, what I have is the altitude is equal to x times root 3 over 2. And again, that suggests a pattern that's always going to work for all 30, 60, 90 right triangles. In general, if you have a 30, 60, 90, then the hypotenuse is always the longest side, and it's across from the 90-degree angle. The short leg is going to be across from the 30-degree angle, and the longer leg will be across from the 60-degree angle. And the pattern will be the 30-degree angle is always half the hypotenuse, and the side opposite the 60-degree angle is always a shorter side times the square root of 3. So there's a little bit easier way to write this, and that would be if the smallest side is x, then the hypotenuse is going to be 2x, and the side opposite the 60-degree angle is going to be x times the square root of 3. This pattern always appears in 30, 60, 90 right triangles. So because these two triangles are fairly popular in mathematics, and they're used quite a bit in geometry and in trigonometry, we call them the two special right triangles. So again, we could practice. If we know the hypotenuse is 20, then that means the short side is going to be half of that length. It would have to be 10. Once we know the short side, we take that and multiply it by the square root of 3 to get the side opposite the 60-degree angle. Try a little bit more here. If we know the hypotenuse is 28, then the side opposite the 30 is half of that, 14. And the side opposite the 60-degree angle is equal to 14 root 3. If I know the short side is 8, the hypotenuse would have to be double that. And the side opposite the 60-degree angle would be 8 times the square root of 3. If you know that's 9 root 3 across from the 60-degree angle, the short side would have to be 9. And then the hypotenuse would have to be 18. Try a few on your own. You can pause the video if you're trying to figure out these two sides. All right, this one's a little bit tricky because it has a fraction, but just that 7 root 2, I mean 7 over 2, 7 over 2 is the length of the short side. Just take away the square root of 3. And if you double 7 over 2, you just get 7. Try this one on your own. You can pause again if you're trying to think about it. What's double 9 over 2? What's 9 over 2 times the square root of 3? Okay, on this one, think about doubling 2 root 3 to get the hypotenuse. Double 2 root 3 should be 4 root 3. And here, carefully think about when you multiply 2 root 3 times root 3, what will you get? You can pause this. 2 root 3 times root 3 should be 6. Okay, this one's one of the more tricky problems where you got to think again, some number times the square root of 3 is equal to 12. So here, I usually take the number divided by 3. 12 divided by 3 is 4. If I attach a root 3 with that, 4 root 3 times root 3 will give me 12. So the short side should be 4 root 3. And then if I double that, it would be 8 root 3. All right, so we can look at both patterns again. There's only two special right triangles. They are the 45, 45, 90, and the pattern is x, x, x times the square root of 2, and the 30, 60, 90, which would be short side of x, the hypotenuse of 2x, and side opposite the 60-degree angle is x root 3. So the rest of this is mixed practice, and you should work through them. The answers will appear. You should pause each time we get to a new slide. Think about what the two missing sides would be, and then check your work. I'm just going to progress through the slides, and you'll have to check your work by pausing and checking as you go through them.